Hello, Math Dog here. This video should be watched after either looking at my videos or slope, or you're somewhat familiar with how to calculate slope, particularly from a graph. So we're looking at some basic problems using slope here. I have this listed as grade 7 in the Common Core, but it could be grade 8, grade 9, could be used as a review of how to find slope, particularly from a graph here. So again, this video is not to be shared or reproduced without the written consent of myself, the Math Dog. So starting out, the graph below plots cost in dollars versus pounds for two brands of coffee, A and B. So notice I have labeled the horizontal axis as coffee. The units here are pounds. The vertical axis is in dollars. So 2 pounds, 4 pounds, 6 pounds, 8 pounds, 0 pounds, $4, $8, $12, $16, $20, etc. So we have two brands of coffee, A and B, and this is showing at different amounts, the price, the cost. Okay. So what is the cost per pound for brand A? Well, notice cost per pound is the vertical change over the horizontal change, and in this case that's going to be dollars per pound. So actually this will be the slope of these lines. So let's start. We know we're at 0, 0. That's the easiest thing to do here, and doesn't quite, so look at the blue line, doesn't really quite go through 8 there, but it does appear to go through the point 212. So if we draw a slope triangle under there, for every 2 pounds that's $12. So for A, $12 per 2 pounds gives a unit rate of $6 per pound. So that is this should be for B, A. So from the graph we can calculate the rate or the cost per pound of coffee, which is the slope. So notice then, if we did say 4 pounds, we would have a total of $24. Well, 24 divided by 4 is 6, and that is the slope. You notice you're going up. For every 2 pounds you're going up $12, and that is a constant rate. So the slope there is $6 per pound, and that answers our question there. So for brand A it's $6 per pound. Now, did I say that's B? Okay, so now A, if I start at 0, let's see what it goes through. Well, it looks like it's going through right there. So for every 2 pounds that's $4. So that unit rate, which is a unit rate, is the amount per unit. Well, the unit here is pounds, so it is $2 per pound. See, we're going for every 2 over, going 4 up, because my units are going up by 4 here, so every tick mark here is actually $2. And that is the slope. Okay, we could have gone up. My graph's off a little here. Let's try to see if we can fix that. That's a little better. So I could have gone over 1 and up 1 instead of 2 over 2 up. Well, 1 over here that's 1 unit, and each tick mark's 2. So you could directly get the unit rate there. That's $2 per pound doing that, instead of going 2 over 2 up. I went 2 over 2 up there, I guess, because I thought it was a little more obvious, but you could do it the other way. So we have brand B. I got this backwards, don't I? Brand A is actually supposed to be, this is supposed to be $6 a pound. Brand A is $2 a pound, so let's fix that. That should be per pound. I need a division sign there. So by the way, when I write $2 per pound, these are just different ways of writing the same thing. The slash mark means division 2, if you're not aware of that. So what would the cost be of 100 pounds of brand A? Well, if it's at $2 a pound, that's just going to be $100 times for every $2. Well, let's start. That's not. Sorry. So let's start. We got 100 pounds of coffee we want, okay? So for every 1 pound, it's $2. Pounds cancel, so that's $200. And then for brand B, if I want 100 pounds, I'm going to do this over here. If I got 100 pounds, for every 1 pound, it's $6. So that's going to be $600. And slope, we already said, slope is change in Y or change in vertical or change in horizontal. Well, so that's going to be the slope here. The units of slope are going to be dollars per pound, or change in dollars over change in pound. Delta dollars, delta pound, which is dollars. The units are dollars per pound, so that is the cost per pound of the coffee. That's what the slope represents for the different brands. All right, so now is another example. Suppose we have two motorcycles, B and A. B has a greater book value than A, at least initially. So this also is wrong, because actually A has a greater book value than B. So I'll show you why. So I got to fix that. Okay, so A at time 0 has a book value of $10,000. B has a book value of $8,000. So book value is the estimated dollar value of something at a given point in time. So at time 0, like right now, the way we wrote the problem, or I wrote the problem, motorcycle A has a book value of $10,000. B has a book value of $8,000. There's things like Kelly Blue Book and stuff like that that post book values. That doesn't mean that's what you could sell the motorcycle for, but that's based on its condition, that's a good estimate. That's where people tend to start with. Another term we're going to need here is depreciation. That's the dollar value loss in value of something over time. So like again, if you have a car and you keep driving it, it's going to lose value over time because it wears out. That's what depreciation is. Okay, car may be worth $10,000 today, but at 2 years from now, it's not going to be worth $10,000 anymore. And that's what this graph shows. Notice that in this problem, the slope of A and B is negative, so the value over time, because this is time in years versus book value dollars, it's dropping for each of these. Then at time 0, the value of 0 for each of these motorcycles is roughly 5 years. It looks like 5 years for A, motorcycle A, and 10 years for motorcycle B. So at 10 years, according to this graph, the value of motorcycle B is 0. So that basically means it's probably been junked. Usually there's a thing in reality called salvage value, but we're not going to deal with that here. So let's ask some questions. What does the slope represent in this problem? Well, from the last problem, it's going to be dollars per year, and it's decreasing. That's actually the depreciation. So that's the loss in value. It's the loss in dollars per year. And remember, the word per means division. So we could write this as dollars per year loss, because it's a decline. It's going to be declining. So the rate of depreciation for motorcycle A, well, let's start here. Let's do the easiest thing. So this is a constant rate of change. It's a straight line. It's linear. So notice that A, over a 5-year period, the value drops $10,000. You can see that from the graph. So A is going to be negative $10,000 over, so that's 5 here, that's 10,000 down. So 10,000 divided by 5 is 2,000, it's negative 10,000, so it's negative $2,000 per year. That's the depreciation of motorcycle A. Now B, we can just take the easiest, that's what I'm trying to do, I'm taking the easiest 2 points on the graph. So that's 8,000, it drops $8,000 in 10 years, so that's negative 8,000 over 10 years. Well, that's going to be negative $800 per year. So A is negative $2,000 per year, and B is negative $800 per year. So A has more initial value, but it depreciates faster than B. So from the graph, estimate how much, this should say how much more. So from the graph, estimate how much more motorcycle A is worth than motorcycle B after 5 years. Well, what we're going to do is we're estimate that. So let's draw a vertical line here at 5. Okay, so I'm going, that's not what I want to do. I'm trying to draw a line here. Let's just do this. Okay, so 5 years right there. So the difference is going to be how much this is right here. Well, A is worth $0 at this time, and B is worth, looks like 4,000. So B, actually A is not worth more than B. It has 0 value, so it's actually should be motorcycle B, shouldn't it, than motorcycle A. So it's $4,000. Okay, now I want you to do a problem here. Stop the video. So we have car A and B starting at the same spot and traveling down a highway. So this is car A, this is car B. The horizontal axis is time in hours. The vertical axis is distance in miles. So I want you to answer these questions. So we'll do one at a time here. So question 1 is, how fast in miles per hour is car A traveling and car B traveling? Now they're traveling at a constant rate because the graph is a straight line. But I want you to stop the video and calculate in other words, calculate the distance per hour that these cars travel, which is usually in layman's terms, that's called speed. We also we call it velocity, but we're not going to distinguish here between speed and velocity. So figure it out and then start the video again. All right, so car A, I'm going to use 0, 0 for each of these, and I'm going to use 1 hour 20 miles. So car A in 1 hour appears to be traveling 20 miles. So A is 20 miles per hour. That's the unit rate. That's the velocity or speed. B it looks like in 2 hours, B goes 10 miles. So 10 miles per 2 hours gives a unit rate of 5 miles per hour. So that's the result of question 1. Question 2, after 2 hours, how much further has car A gone than car B? So after 2 hours, how much further has car A gone than car B? So stop the video and answer that question. Okay, so after 2 hours, there's 2 hours on the graph right here. So, oops, let's try that again. Okay, there's 2 hours. That's a vertical line. Try it again. Okay, now let's mark on that vertical line where 2 hours is for car B, and then for car A. Well, car A's gone 40 miles. Car B is only gone 10, so the difference is 40 minus 30 miles. Sorry, 40 minus 10 miles is 30 miles. So car A has gone 30 miles further than car B. And again, what does the slope represent in this problem? Well, it represents vertical change divided by horizontal change. So that's miles. That's miles per hour. Which we often call velocity or speed. Okay, last question here. I'll stop the video. Let's make sure, did I answer question 3 back there? Let's check that. Yes, I did. All right, so last question. A water tank is drained. A graph is shown below. This is gallons versus time. So the first question is, what does the slope represent in this problem? Stop the video and answer that question. Notice also, is the graph increasing or decreasing? Okay, so the slope has to be gallons per hour. It's vertical change divided by horizontal change. So that's gallons per hour. And that's actually going out, so it's the gallons per hour leaving. Actually, that's minutes, not hours. The units here are minutes. Let's fix that. It's gallons per minute. And that's leaving the tank because it's a negative quantity. Okay. So second question is, how fast is the water draining from the tank? Well, the easiest way is to take that point and that point, which we can clearly see what they are. This is 0, 300. This is 4, 0. So you can just draw a slope triangle. That's negative 300 gallons per 4 minutes. Well, 4 goes to 375 times, so that's negative 75 gallons per minute. Again, you could do this without using the graph. You could make a slope table. We talked about that in the slope video. So this would be minutes. That's the horizontal axis. This would be gallons. You have the point 0, 300. You have the point 4, 0. So if I'm going to go this way, so the change in gallons over change in minutes is 300 minus 0 over 0 minus 4, which is negative 75 gallons per minute. So how fast is the water drained from the tank? Again, we talked above, slope represents gallons per minute, leaving tank. And it's draining out at negative 75 gallons per minute. So then the last question is how much water is left in the tank after 2 minutes? I'll stop the video and answer that question. Okay, so how much is left in the tank after 2 minutes? Well, there's 2 minutes. Go up from 2 minutes and you see that it takes us to here. You go across, that's got to be 150. So there's 150 gallons left in the tank after 2 minutes. And this concludes the video.